This video is for Math 70, and this assignment is on parallel and perpendicular lines. So let's talk about parallel and perpendicular lines for a minute before we get started. The key to this topic is the slopes of these lines. Okay? So there's two lines that are parallel to each other. And the fundamental idea here is that parallel lines have the same slope. Because for them to be parallel, every time you go over on the x's, you have to go up the same amount on the y's for these lines to stay parallel. If you didn't go up quite enough, then they would intersect here. If you went up too much, then they would intersect up there. Okay? For them to stay parallel, these slopes, the change in y's over the change in x's, have to be exactly the same. So, parallel lines have the same slope. Okay, and we could go through like a geometric proof of that, you know. It's kind of interesting. I won't do it, but just the general idea is that the fact that these are parallel means that those are right angles, and then if you draw some lines through here, you can create some similar triangles, and that will show that their sides are proportional, which means that these slopes, which are based on the sides of those triangles, have to be the same. All right, what about perpendicular lines? Well, with perpendicular lines, the right angle comes here. And what happens with the perpendicular lines, well, for one thing, one slope is positive, the other slope has to be negative, otherwise they won't be perpendicular to each other. Let's see, the other thing that's going on here, so there's the change in y over the change in x's for that one, and there's the change in y over the change in x's for that one. Now these are also similar triangles, except what's happening here is that this angle is congruent to that angle, and that angle is congruent to that angle. And so their sides are kind of switched with each other, okay? Which means that this side corresponds to this side down here, whereas this side corresponds to this side over here. The x's and the y's are switched. And so what happens with the perpendicular lines, is that for one thing, if one slope is positive, the other is negative, and vice versa, and also they will be reciprocals of each other. Okay? So, like if this one is positive 1/2, this one will be negative 2/1. Alright? And we'll see some more examples of that. But this is the fundamental idea for working with parallel and perpendicular lines. So let's take a look at some of these exercises. So they start out where you're given two lines, and I ask you, are these lines parallel, are they perpendicular, or are they neither? Okay, so here's an example of two lines that are neither parallel nor perpendicular. Okay, so they're not parallel because they do intersect each other, and they're not perpendicular because they don't intersect at a right angle. Okay, in fact, both of those slopes are positive, so that's an example of neither. Okay, so problem 2, we've got the line y equals negative 4x plus 1, and 4y equals x plus 3. Well, for one thing, it's good to put these both into slope-intercept form. So I'm going to get the y by itself here. This will be 1/4 x plus 3/4. Well, what we're interested in here is the slopes, the value of m in y equals mx plus b. Okay? And you can see this one is negative 4 over 1. This one is positive 1 over 4. Those are negative reciprocals. Okay? They've been flipped and the sign has been changed. And so problem 2, neither. That's not the case. Problem 2 is perpendicular. These lines are perpendicular to each other. And you don't have to graph these, but let me just draw a little sketch here. Negative 4x plus 1 would look something like that. This one, positive 1/4 x plus 3/4. It's going to be something like this. I mean, I'm cheating a little bit because I know that they're perpendicular, but this is essentially what we would see. So there's the positive 1/4 slope, and there's the negative 4 slope. Okay, and those two lines are perpendicular to each other. Okay, let's see here. Problem 4. Y equals 2/3 x plus 1, and 6y equals 4x minus 7. Let's get a little bit better there. 4x minus 7. All right, there we go. All right, well, let's divide everything through by 6 again so that we get this into slope-intercept form. Now, I'm reducing this fraction as I'm doing this problem, and so here it is. You've got this slope is 2/3, this slope is also 2/3, and so these two lines are parallel to each other. And again, you don't have to graph this, but let's see, there's the first line would look something like this, and then the other one, minus 7/6, 2/3, so something along those lines. And again, I'm cheating a little bit because I know that they're parallel, but if I did it carefully, it would not look much different than this at all. Okay. All right. Let's finish off the problems on the top of the page here. Problem 6. We've got y equals negative 1/3 x plus 2. And y equals 3x minus 5. Well, these are both in slope-intercept form, so there's not a whole lot to do except to examine the slopes here. Okay? You can see one slope is a positive 3, the other slope is a negative 1/3. Those are negative reciprocals of each other, and so these lines should be perpendicular to each other. Problem 8, y equals 2x minus 5, and 4x plus 2y equals 9. Okay, so for this one, this is in slope-intercept form, that's nice. Here we've got to get the y by itself, so let's move the 4x to the other side. 2y is negative 4x plus 9. And then divide everything through by 2. Negative 2x, and you can leave it as 9 over 2 if you want. So this is a positive 2x, this is a negative 2x. Now, they are negatives of each other, but they are not negative reciprocals, okay? I mean, if we graph these lines, let's see, 2x minus 5 looks something like this. And negative 2x plus 4.5 would be something like that. And you can see that angle in there is not a right angle. It's not 90 degrees. These are not perpendicular to each other. They're obviously not parallel either. And so that's a good example where we have neither parallel nor perpendicular. Problem 10. 3x plus 4y equals got some work to do here to put these into slope-intercept form so that we can see what their slopes are. I mean, that's the key to this whole issue. I didn't write the word slope on here, but I will when I get some space. Okay, this is all about slopes. All right, let's see. So take our 3x plus 4y equals 8, and let's get the y by itself. So I'll move the 3x over here, and then divide everything through by 4. So this is negative 3/4 x plus 2. All right. Well, that's going to be helpful. Here, let's see. I'll add the 12y to both sides and subtract the 9x on both sides. So let's see here. Those cancel out. Here we'll have 12y, negative 9x plus 7. And now we've got to divide everything through by 12. So here you've got to reduce. Okay, divide them both by 3 and you'll get negative 3/4. And that's the key to seeing that these lines are parallel to each other. They both have a slope of negative 3/4, and therefore these lines are parallel. All right, one more in this section here, problem 12. Let's see what we get. 5 minus 3x and 3x minus y equals 8. Okay, well, so this y is by itself, but don't get fooled because this is not mx plus b form, but you can still pick out the slope, okay? It's just in b plus mx form, all right? It's just, don't think that the slope is 5 just because it comes first, all right? The slope is always the coefficient of the x when you get the y by itself. So let's get this y by itself. I'll add y and subtract 8, so y is going to be 3x minus 8. Here the slope is positive 3. So this is very similar to that last problem we saw that was neither parallel nor perpendicular. Right? This has a slope of positive 3, this has a slope of negative 3, and so this is neither parallel nor perpendicular. Okay, so that's that part of the worksheet, kind of an introduction to parallel and perpendicular lines, picking out when they're parallel, when they're perpendicular, and when neither is true. Okay? But this is all about the slopes of those lines, right? So, let's look at these problems on the bottom of the first page. In problem 14, want to write the equation of the line that is parallel to the given line. That's the symbol for parallel. And passes through the given point. Okay? So let's see here. We've got y equals x minus 4, and we want this to pass through the point negative 2, 3. Now, you don't have to graph these to do them, but I've taken to drawing graphs every time I do this, just to make sure people understand we're talking about two different lines here. This is one line, y equals x minus 4. It's going to look something like this. The slope for y equals x minus 4, positive 1, right? 1x minus 4. So the slope is positive 1. Now, the idea here is that we want a parallel line that's going to pass through the point negative 2, positive 3. So that's going to be up here somewhere. So this is the line y equals x minus 4. This is on some other line. Its slope is going to be 1, but we don't know what the y-intercept is. So we write an equation, y equals 1x plus b, and then do the same thing we did in one of those previous assignments, plug in the x and y coordinates of this point that it's passing through, where y is 3, x is negative 2, and so that means b is going to be equal to 5. And there we go. That's our answer. Y equals x plus 5. You can call it y equals 1x plus 5. That's fine. It's the same thing. But this is what's happening. We're talking about two different lines. The line we're given in the problem, and then the line that we're being asked to find that is passing through some other point but parallel to the original line. Okay, that's problem 14. Let's take a look at problem 16. All right, 16, same thing. We want these parallel. Parallel to y equals negative 2x plus 4, and passing through the point negative 1, 3. Okay, so the slope in this situation is negative 2. So again, you don't have to draw these, but I'm going to draw this picture just to help make sure people understand we're talking about two different lines. Negative 2x plus 4 is going to look something like this. So we want a line parallel to this that's passing through the point negative 1, 3. So that's going to be here. They're going to be pretty close to each other. Okay? But they are going to be different lines. Now this one is going to have a slope of negative 2. And we need to find out what is that y-intercept going to be. And the way to go about doing that is to set up our equation, y equals negative 2x plus b, and then plug these values for x and y into the equation. 3, negative 2 times negative 1 plus b. And so in this situation, b is equal to 1. And so the answer for this problem, y equals negative 2x plus 1. That's the equation of this line right here. Okay, let's take a look at a couple more. These are going to be perpendicular to a certain line and then passing through a given point. So, problem 18. The line we're interested in first is y equals 2x minus 3, and we want it passing through the point 8, negative 5. Well, again, I'll draw a picture for this. You don't necessarily have to. All you really have to do is that algebraic work that I'm going to do in a minute. But again, I want to emphasize to people there are two different lines we're talking about. First, this one, y equals 2x minus 3. So something like that. Now, we want a line that's going to pass through the point 8, negative 5, so over here somewhere. And we want it to be perpendicular to our original line. Okay? That means our slope here is got to be negative 1/2, the negative reciprocal of this line. Okay? We need to find out what's the y-intercept. The way to do that is to plug these values in. So y is negative 1/2 x plus b. So y is negative 5. X is positive 8. So that'll be negative 4. Add 4 to both sides. B is negative 1. So that's not a bad picture. You can see that y-intercept makes sense that that's negative 1. So our answer to the problem here, y equals negative 1/2 x minus 1. Okay, one more on this assignment. And we'll have a follow-up assignment after this. That will give you more practice doing this, because you can expect to see this on the final exam. Problem 20. So we want it perpendicular to y equals negative 3/5 x minus 7. and we want it to pass through the point negative 3, 10. Okay, well, let's see here. Go down to negative 7, and then negative 3/5. That's going to look something along those lines. Okay, negative 3/5 x minus 7. Okay. Now, we want a line that's going to be perpendicular to this, but also pass through the point negative 3, positive 10. And so let's see, perpendicular is going to come down right like that. So there's our line, okay? The slope here has to be positive 5/3. That's the negative reciprocal. And then we'll find out what the y-intercept is in a minute. So positive 5/3x plus b. Y is 10. X is negative 3. These cancel, give us negative 5. Add 5 to both sides. B in this case is going to be 15. So our answer here is 5/3 x plus 15. Does that make sense in our picture? Yeah. If we extend this y-axis up some more, it seems reasonable that that y-intercept is going to be up at 15 or thereabouts. Okay? All right. So that's the introduction to this idea about parallel and perpendicular lines and what that says about their slope. All right. And I mentioned we'll have a follow-up assignment on this so we get a little bit more practice. As always, if you have any questions, please let me know. Thank you.